Hello, this is Sarah Hardy at the University of Maine at Farmington, and this is a video tutorial about fitting a quadratic surface with two variables to a response variable. So I have already selected the balloons data set for this example, and so I will start by fitting the model. So I'm going to go to Fit Model, Linear Model, and my response variable is time. And over here I want to include both floor and size, and I want to include a linear term as well as a quadratic term. So I'm just going to type this in, and as mentioned in the earlier video, anytime you have an arithmetic operator in one of the actual terms, like this squared operator, you need to put that in the I or as is function. So okay. And then we can just hit OK. And that will give us the output, and you can see all the different terms, whether or not they're significant, and go from there. To do the graph of the surface, we're going to go to Graph, 3D Graph, 3D Scatter Plot. Okay, so then when this box comes up, select your response variable, which is time. Select the explanatory variables, which was floor and size. Okay. Use control to select more than one. I'm going to leave that the way it is. Show axis scales, show surface grid lines. I'm going to uncheck linear least squares and check quadratic least squares. Linear least squares would just fit a plane. Check quadratic least squares. Okay, I think I have everything now. Hit OK. Here, in your plotting window, you will get a graph of your surface, and you can move that graph around to take different looks at it. It's going to actually show you the points as well as the surface that was fit through it, so you can see how much they're scattered around. And so that's really about it. So there's one more thing I'd like to show you about the 3D graphs, and to demonstrate this, I've selected a different data set, XYZ Sim, and this is just some simulated data that I generated. So let's view that data set. And so in this data set, I also have a categorical variable with treatment, which is A or B, and two numeric explanatory and a numeric response. Okay, so I'm going to go over here to my graphs. Again, 3D graph, 3D scatter plot. Response is Z. Explanatory is X and Y. I want a quadratic surface, and I will hit OK. And that produces this plot here. Well, what I'd like to see is, does the surface look different for the two different treatments? Okay, so to do that, I'm going to repeat the same thing. 3D graph, 3D scatter plot, Z, X and Y, quadratic. This time I'm going to select plot by groups. Okay. And so I only have one factor or categorical variable, so it's selecting that automatically for me. And this says, do I want to force those two surfaces to be parallel and to do the best fit and make them parallel? And I do not want to do that, so I'm going to uncheck that and hit OK. And then hit OK. And so now we can see that actually, for the two different treatments, these surfaces do look different. So if you were to observe something like this, you would probably want to go back to fit your linear model. And you fit it the same way, but use the subset expression. So here I'm saying, now I just want to fit the model where the treatment equals A, and reminder that you have to do a double equal sign anytime you're doing a subset expression. And then I can redo this for just treatment A and then for treatment B. So I think that that is about it for this video. So thank you for watching, and goodbye.